Good morning, biology students, and welcome to Block 2 of your ecology engagement. This block focuses on population dynamics, and one of the things that we're going to do is begin our unit-long experiment on a fruit fly population to see what affects their density and growth rates. So in order to do that, we have to understand some components of the scientific process. So I'm going to give you a little bit of information over 2 videos on the first 2 steps of the scientific process. So bear with us. It shouldn't take too long, but it will certainly set you up. I really recommend taking some notes during this quick little lecture, and there are some things I recommend when you take notes. To begin with, I told you several weeks ago that I love it if you get those four color clicky pens, and if you have them, that's really going to line up with the way that these notes are set up. If you take a look here, the way I set up my notes and the way they'll be set up in this presentation, black is sort of the default color, red is for important points, blue is for activities for you to do, and there won't be too many of those in this lecture. Green is for examples, and I put a box around things I'm defining. You can pause the video as you need to write down definitions or put them into your notes as you see fit. But this is a good way to think about the way our lecture is set up. You can write this in pencil if you want. It's up to you, but this is a good way to look at the notes, and this is how they're set up in lecture. Okay, so moving on. One of the things you'll find attached from your assignment is this great circle of truth. When we're going through the scientific process, we're trying to figure out what's actually true. And that's represented in this picture by the sun in the center, the great ball of fire of enlightenment. We'd like to figure out what's actually going on in the world. And the best way to do that is to run experiments and trust the scientific process. But much like in the medicine wheel in Native American mythology, you can't go straight to the fire. You can't get straight to the truth. You have to go around and around the wheel each time, getting a little bit more knowledge and getting a little closer to the actual truth. So I use this as a method for setting up our scientific process. So every time we run an experiment, we start by making observations. After doing that, we move on to developing a hypothesis, analyzing our results, developing a conclusion, and sharing our results. And usually after that, we go on to another experiment that maybe is a little bit more detailed and focuses in on some specific findings of the first experiment, and we keep going and going and going until eventually we get to the place where we understand what's going on. So this is a good place for you to have as a note taker. The PDF attached, you can print it out or you can write directly on it, but I would recommend having this as part of your kind of synthesis of your notes too. So to begin with, this discussion is about observations. So our focus today is going to be on the 2 different kinds of observations and making sure you understand what an observation is. So that's what we're going to talk about. Here we go. Okay, so an observation. An observation, again, you'll notice it's in red and boxed, which means it's an important thing and it's a definition. An observation is something you perceive with 1 or more of your 5 senses. You can touch, taste, feel, hear, or smell it. These are things that there's no debate about. They're just simply what's going on unless there's something wrong with one of your senses. So here are a couple of examples, and if you know already, they're going to be in green. So here's one. This text is in green. You can see it. There's no debate about it unless there's something wrong with your phone. But this text is present in green. That's an observation. In this video, there's a person wearing a gray hoodie. Hope you can see that. Again, it's something we can see, so something you can perceive with 1 of your 5 senses. And then this one, this sentence takes up about 70% the width of the screen. If you look at your entire screen, this sentence takes up more than half. It's probably about right. But these are all things we can see with our senses. We can use other senses to make observations too. Maybe the desk in front of you is cold. Maybe you smell a little bit of a smoky sense because of the air today. Whatever it is, we can add our other senses as well. But observations are inarguable things that we perceive with our senses. Some statements we think are observations really aren't, and we need to be careful about this. So here are a couple of examples. First of all, the person in the corner is Mr. Clapp. Well, you've been told that my name is Mr. Clapp, but I could be lying to you the whole time. You just simply can't perceive that I am Mr. Clapp by looking at me. It's a pretty good guess, but you can't prove it by looking at it. It's not like I'm wearing a gray hoodie. That's something you can see. You can't see me being Mr. Clapp. We are expected to turn in a hypothesis using teams. Well, we've told you that, and that certainly is something that you should be doing, but it's not an observation. It's not something you can touch, taste, feel, hear, or smell. Maybe we're lying to you. Maybe we don't expect you to turn it in, and we're just trying to set you up for failure. Not true. But maybe that's true. You can't see this, so it's not an actual observation. We did not go to school today due to smoke. Well, that certainly seems to be what's going on, but you can't see that. You can't touch, taste, feel, or hear it. Yes, you may have received a phone call this morning, but again, we don't know that the real reason wasn't because the superintendent wanted a day off. Who knows? It's a good guess. If you can't touch, taste, feel, or hear it, or smell it, it's not an observation. A lot of the problems in science is when people try to claim things are observations that are not. So make sure your observations are locked tight and are very, very clear before you move on. There are two different types of observations. One type of observations is quantitative. Quantitative observations involve counting or measuring, and they have numbers in them. The word quantity is in the word quantitative observations. It should make sense to you that that means they have numbers. So here are some examples. To begin with, there are 4 lines of red text above. 1, 2, 3, 4. We can count them. Therefore, it's a quantitative observation. We count it. You have not been to school in person in at least 6 days. Unless this isn't the case for you, most of us haven't been to school in 6 days. We can count the days. That's quantitative. Your phone weighs under 1 pound. Unless you have some very interesting phone, this is also the case for you. So again, all of these are quantitative observations. When making quantitative observations in science, we generally use the metric system when we're measuring things and not just counting them. So briefly, we're going to go over the metric system. To begin with, when you're measuring things of length in the metric system, you use the base unit of meters, and you can break that down into tenths in decimeters, hundredths in centimeters, and thousandths in millimeters. You can also take 1,000 meters together and make a kilometer. And we can measure various things using these values. We also use the metric system to measure volume, or how much space something takes up. The base unit of volume in the metric system is the liter. And a liter, you guys know what a 2-liter bottle is, so a liter is just one of those. Come on, Mr. Magula, let's check out a liter. Hey, so this is a liter. This is a quart in the standard system, and a liter in the metric system are almost the same size. So this bottle contains a liter of liquid, or at least can contain a liter of liquid. And we also use milliliters. A milliliter is about the size of a Lego head, and that's a pretty good unit of measurement as well. And then finally, for mass we use grams. A gram is about the weight of a paper clip, and we also use kilograms, which is 1,000 paper clips together, or 1,000 grams. And something like a big combat boot is about the weight of a kilogram. So again, we use all these different things in the metric system to measure in science, but a lot of times we're just counting. And in our purposes for this fruit fly experiment, although we might measure out the food by mass or volume, we're generally going to be measuring based on just counting the numbers of flies. So it's just for your information, in the scientific process, almost always use the metric system. So we can talk in an international community with the system that makes sense. The other type of observations are qualitative. And qualitative observations do not have numbers in them. They generally have less information, and they speak to the quality of the objects as opposed to the number of objects. In this case, we're talking about color, texture, location, or something like that. So here are some qualitative observations. Most of this screen is white. Again, I could add information to this, do some calculations, and maybe I find out that 73% of the screen is white. Then I have a quantitative observation, but as it is, it's qualitative. There is audio in this video. Well, hopefully you're hearing me. Hopefully there is audio for you. That's something you can hear, so that's a qualitative observation. If you measured the volume of this, that would be something that would then be quantitative. You had some units to measure. Again, adding information. And finally, the sun appears more red than it did a week ago at the same time. Again, you got to think back a little bit. Maybe you could measure this, but as it is here, this is just a qualitative observation. Okay, so making observations, a big part of science. And again, here are the different definitions that are important. An observation is something you perceive with one of your senses. Quantitative observations have measuring or counting, and qualitative observations do not. When we use science, we love quantitative observations. As much as we can, we focus on quantitative observations, not qualitative. They simply have more information, and they allow us to manipulate the numbers later on. If we're doing our fruit fly experiment, and at the end we're like, yeah, there are more fruit flies in one than another. Well, how many more? How do you know there are more? Well, we need to start talking about counting. So we like to focus on quantitative observations. So if you take a look at your circle of truth, what I recommend you add to it at this point is on that outside edge, put in some of the same text that I have here that helps remind you what observations are. Observations are made with your senses. We want them to be very simple and inarguable. I circled quantitative here because, like I said before, we prefer quantitative observations. And finally, there's metric system written on the left there, just to indicate that we prefer measurements in the metric system. Join us for part 2 on developing hypotheses based on our observations if you feel like it. Thanks a lot.